Hey, how's it going, guys? This is ndupree, System Security 2, ISA 4220. I'm gonna talk a little bit about SSH today, and we're gonna go ahead and jump into it. So, what is SSH? Also known as the Secure Socket Shell. Um, it's a network protocol that gives users, particular system administrators, secure way to access a computer over an unsecure network. SSH also refers to the suite of utilities that implement the SSH protocol. Secure Shell provides strong authentication and encrypted data communications between two computers connecting over an open network, such as the internet. SSH is widely used by network admins for managing systems and applications remotely, allowing them to log into another computer over a network, execute commands, and move files from one computer to another. Um, SSH refers both to the cryptographic network protocol and to the suite of utilities that implement that protocol. SSH uses a client-server model, connecting a secure shell client application, the end at which the session is displayed with an SSH server. Um, SSH implementations often include support for application protocols used for terminal emulation or file transfers. Um, Also, SSH can be used to create secure tunnels for other application protocols. Um, for example, to like securely run X Windows system, graphical sessions remotely, and an SSH server by default listens on the standard transmission control protocol TCP port 22. SSH relies more often on public key pairs to authenticate hosts to each other. Individual users must still use their user ID and password or any other authentication method to connect to the remote host itself, but the local machine and the remote machine authenticate separately to each other. This is accomplished by generating a unique public key pair for each host in the communication. A single session requires two public key pairs, one public key pair to authenticate the remote machine to the local machine, and a second public key pair to authenticate the local machine to the remote machine. SSH connections have been used to secure many different types of communications between a local machine and a remote host, including secure remote access to resources, remote execution of commands, delivery of software patches and updates, and other administrative or management tasks. Some capabilities of SSH: secure remote access to the SSH-enabled network systems or devices for users as well as automated processes, secure and interactive file transfer sessions, automated and secured file transfers, secure issuance of commands on remote devices or systems, and secure management of network infrastructure components. But SSH can be used interactively to enable terminal sessions and should be used of the less secure telnet program. SSH is also commonly used in scripts and other software to enable programs and systems to remotely and securely access data and other resources. But yeah, so Secure Shell was created to replace insecure terminal emulation or login programs like Telnet. Um, SSH enables the same functions like logging into and running terminal sessions on remote systems, and SSH also replaces file transfer programs um, such as FTP and RCP. In order to secure transmission of information, SSH employs a number of different types of data manipulation techniques at various points in the transaction. These can include forms of symmetrical encryption and asymmetrical encryption. Um, Symmetrical encryption is a type of encryption where one key can be used to encrypt messages to the opposite party. and also to decrypt the messages received from the other participant. This means that anyone who holds the key can encrypt and decrypt messages to anyone else holding the key. This type of encryption scheme is often called shared secret encryption or secret key encryption. There is typically only a single key that is used for all operations, or a pair of keys where the relationship is easy to discover and trivial to derive the opposite key. Symmetric keys are used by SSH in order to encrypt the entire connection. Contrary to what some users assume, public-private asymmetrical key pairs that can be created are only used for authentication, not the encryption, the encrypting the connection. The symmetrical encryption allows even password authentications to be protected against snooping. The client and server both contribute toward establishing this key, and the resulting secret is never known to the outside parties. The secret key is created through a process known as a key exchange algorithm. This exchange results in the server and client both arriving at the same key independently by sharing certain pieces of public data and manipulating them with a certain secret data. This process is explained in greater. Let's talk about asymmetrical encryption. It's a little different from symmetrical encryption. It sends data in a single direction. Two associated keys are needed. One of these keys is known as the private key, while the other is called the public key. The public key can be freely shared with any party it's associated with its paired key, but the private key cannot be derived from the public key. The relationship between the public key and the private key allows the public key to encrypt messages that can be only decrypted by the private key. This is a one-way ability, meaning that the public key has no ability to decrypt the message it writes, nor can it decrypt anything the private key may send it. The private key should be kept entirely secret and should never be shared with another party. This is a key requirement for the public key to work. The private key is the only component capable of decrypting messages that were encrypted using the associated public key. SSH utilizes asymmetric encryption in a few different places. During the initial key exchange process used to set up the symmetrical encryption, asymmetrical encryption is used. In this stage, both parties produce temporary key pairs, and exchange the public key in order to produce the shared secret that will be used for symmetrical encryption. After the symmetrical encryption is established in secure communication between the server and the client must authenticate to be allowed access. The server can use the public key in this file to encrypt the challenge message to the client. The client can prove that it is able to decrypt the message. It's demonstrated that its own associated private key, that it owns the associated private key. The server then can set up the environment for the client. So now let's jump into some hardening recommendations for Linux. Use SSH public key based login. Open SSH server supports various authentication. It's recommended that you use public key based authentication. Disable root user login. Before disabling a root user login, make sure regular users can log in as a root. Disable password login. Only public key based logins should be allowed. Limit users SSH access. By default, all systems users can log via SSH using their password or public key. Sometimes you create Linux user accounts for FTP or email purposes. Disable empty passwords. You need to explicitly disallow remote login from accounts with empty passwords. Use strong passwords and passphrase for SSH users keys. Firewall SSH TCP port 22. By doing this, you need to update IP tables. Usually, Open SSH server must only accept connections from your LAN or other remote WAN sites only. Change SSH port and limit IP bonding. By default, SSH listens to all available interfaces and IP address on the system. you want to limit the SSH port binding and change SSH port. Use TCP wrappers. TCP wrapper is a host-based network ACL system. It's used to filter network access to the internet, but OpenSSH does not support TCP wrappers. For SSH crackers, brute force attacks. Brute force is just a method of defeating a cryptographic scheme by trying a large number of possibilities using a single or distributed computer network. You want to rate limit incoming traffic at TCP port 22. Use port knocking. Port knocking is just a method of externally opening ports on a firewall by generating a connection attempt on a set of pre-specified closed ports. Once a correct sequence of connection attempts is received, the firewall rules are then dynamically modified to allow the host which sent the connection attempts to connect to the specific port. Configure IDLE logout timeout interval. Enable a warning banner for SSH users. Disable our host files. Disable host-based authentication. Patch open SSH and operating systems. Crew open SSH, lock down users to their home directories. Users are usually allowed to browse the server directories, such as /etc/bin, and you can protect SSH using OS-based crew or use special tools such as RSSH. Disable open SSH server on client computer, and we're going to jump into hardening recommendations for Windows now. Discover all SSH keys and bring under active management, a first step to eliminating an SSH key sprawl, and properly assessing SSH security risks to discover and inventory all SSH keys, and then reign in centralized control of all keys. Ensure SSH keys are associated with a single individual. Tie SSH keys back to an individual rather than just an account that can be accessed by multiple users. This will provide an effective SSH audit trail and more direct oversight. Enforce minimal levels of user rights through POLP. POLP is a principle of least privileges. Tying SSH keys to granular areas of remote devices so users can only access certain necessary systems. This limits the potential fallout from misuse of SSH keys. Stay attentive to SSH key rotation. Force users to generate keys on a regular basis and disallow use of the same passphrases across multiple accounts or iterations. These actions help protect the organization from password reuse attacks. Eliminate hard-coded SSH keys. SSH keys are one of the many types of credentials that can be embedded within code, such as in applications and files. This practice creates dangerous backdoors for malware and hackers to exploit. Embedded keys that use simple or default passphrases may be vulnerable to password guessing and other attacks. Audit all privileged session activities. Any privileged sessions started via a SSH key authentication should be recorded and audited to meet both cybersecurity and regulatory needs. But that's all I have today for SSH. Thank you for listening.